Okay, so when we have to balance chemical equations with interfering coefficients, what that means that we have an element in more than one different place on the same side of the equation. So for instance, here we have oxygen in the carbon dioxide, oxygen in the water. Ooh, tricky, right? So you mess with the amount of like oxygens, you're messing with it in two different places over here. Fun times, right? So my strategy for this is always to like take care of the most complicated thing first and then leave something simple till last. The simplest thing here is the O2. Now, because this is the combustion reaction of a hydrocarbon, okay, there's the hydrocarbon, the oxygen, products carbon dioxide and water. I have even better strategy. So if it's combustion of a hydrocarbon, this will always help you, I would hope. You're going to balance the carbon and then the hydrogen, and then the oxygen. Okay, so normal strategy, leaving oxygen till last because it's just an element. Okay, carbon and hydrogen, I guess it doesn't really matter. The hydrogen's a little tricky because of the H2O, but there you go. So how many carbons have we got on the left-hand side? 2 carbons, and we got 6 hydrogens, and we got 2 oxygens. Okay, and then on the right-hand side, we got 1 carbon. I see what we're going to do here. And we've got 2 hydrogens and we've got 1, 2, 3 oxygens. Okay, so let's deal with the carbon first. I would just put a 2 in front of the CO2 to fix that. Okay, so then update my accounting here. And I'm also going to have to update my oxygen, don't forget. So now I've got 2 carbons and I've got 2 times 2, which is 4 oxygen. So then I'm going to want to look at my hydrogen next. So I've got 1, 2, 3, 4, 5, 6 on the right-hand side, sorry, left-hand side, 2 on the right-hand side. So I can fix that by sticking a 3 in front of the H2O. So update my accounting. There we go. So instead of having 2 oxygens, now I've got 3 times H2, which is 6 hydrogens. So now my carbons are fixed, my hydrogens are fixed, my oxygens are not. I've got 2 oxygens over here, and I've got, oh, did I update my accounting? No, I did not. See, naughty, naughty, because looky here. Now, if I got 2 times CO2, that's 4 oxygen, and 3 times H2O is 7 oxygens. So this is where these kind of questions can go wrong if you don't keep updating your accounting. So 7 is not balanced with 2. In fact, it's going to be kind of tricky to balance that because of the diatomic O2. So what you could do is find the lowest common multiple, which is do 7 times 2. So we're going to end up with 14 oxygens altogether, okay? Which means we're going to have to times everything by 2. Or you can use a fractional coefficient, which in this case will be 7 divided by 2 in front of that O2, okay? And then you're going to have to times everything by 2 to clear that fraction. So you would end up with 2 times the CH3, CH3. 7 divided by 2 times 2 is going to be 7. So you have 7O2. And then don't forget the 2 CO2 would be multiplied by 2, so 4 CO2, and then the 3 H2O would also be multiplied by 2, so that is going to be 6 H2O. If you're not sure, do your accounting again. Count up all your hydrogens, carbons, and oxygens on each side, and they should be equal. Okay, let's have a look at another one then. What have we got? All right, so let's erase. All right, so we've got iron, oxygen, and water on one side, and iron hydroxide on the other side. So a bit of accounting. 1 times iron, 2 times oxygen. Oh, no. Oxygen's in more than one place. 3 times oxygen, and we've got 2 times hydrogen. See how easy it is to make a little error? And then we've got 1 times iron on the right side, 2 times oxygen, 2 times hydrogen. Okay, so because the oxygen is complex, I want to kind of leave it till last. So at the moment, my hydrogen's balanced, but my oxygen isn't. My iron is balanced, but my oxygen isn't. So I want to end up with like an even number of oxygens because I'm always going to have an even number of oxygens on the right-hand side, and I've got 1, 2, 3 on the left-hand side. So one way to balance this very quickly again is using the fractional coefficient that I could put 1/2 an oxygen here. Okay, so 1/2 an oxygen here is going to knock off one of those oxygens, so it's just going to be 2 oxygens on the left-hand side. But then I would have to multiply the whole thing through by 2 to get my answer. Okay, so that's going to be 2Fe plus O2 plus 2H2O goes to 2FeOH subscript 2. Okay, so that would be balanced. Okay, if you are not a fan of the fractional coefficients, then how would you go about trying to sort this out? Well, oh, whoops, I didn't want to do that. Right, we've got 3 oxygens at the moment. Okay, so you're going to try and squirrel away those oxygens. So lowest common multiple method. So 3 times 2 gives me, I want to have 6 oxygens on each side. So I'm going to want to multiply this by, let's see. If I multiply this by, oh no, because that's going to screw up my iron. Let's not do it that way, actually. Probably the easiest way to do it is to say, well, we're going to deconvolute these later. We're just going to worry about the hydrogen and the iron and leave that oxygen till last. Okay, so at the moment I've got 2 hydrogens, 2 ions. Okay, but I'm going to want to end up with more oxygens. If I have 2 of these, then that's going to give me 4 oxygens. Okay, so let's update all the accounting. Okay, so for iron we'd have 2, for oxygen we'd have 2 times 2, which would be 4 oxygens, and I know I can fix that in a little bit. And then for hydrogen I'm going to have 4. Okay, so then fix my iron over here by sticking a 2 in front of it. That's the easiest fix for now. Okay, all right, so then what else have I got to fix? My hydrogens have increased. So again, if I fix my hydrogen, it's going to change my oxygen too. If I change that so I've got 2 H2O, so that's going to be 4 hydrogens. Now that will match, but it also changed my number of oxygens. So 1, 2, 3, 4 oxygens, that will now match. So done the same thing, okay, but it was just a little bit trickier if I didn't use the fractional coefficient in that case.